Hello Gems, welcome to the second video of A series. In this video, we are going to discuss previous year BitSat questions from the chapter of motion in a straight line or kinematics 1D. Okay, so make sure that you are well versed with all the concepts of motion in a straight line, and if you are not, go check out the description box, and if you are, let's begin without any promotions. Okay, so as always, let us begin the discussion with some easy questions and then we'll keep on increasing the level as the video proceeds. Okay, so first question here on the board, it's from BitSat 2014. You can surely give it a try. Okay, I will do it in 3, 2, 1. Pause and try if you want to. Okay, so the question says a train accelerates uniformly from rest. So the train begins from rest. Initial velocity of the train is 0 and it attains the speed of 40 meters per second. Now that train is accelerated, so it attains that speed of 40 meters per second in 20 seconds. Okay, so one thing we can do, we can find the acceleration, right? Just let's collect the data. Okay, so acceleration is defined as change in velocity by time taken, right? So change in velocity is 40 minus 0, 40, time taken 20 seconds, and this will give us 2 meters per second square, right? So the acceleration in that part of motion is 2 meters per second square. Now the train travels with the same speed for next 20 seconds. So the train maintains the same speed 40 meters per second for next 20 seconds. Now that acceleration is removed, so train maintains that same speed, okay, which is 40 meters per second for next 20 seconds. Then after that, brakes are applied. You can see over here constant retardation. Okay, so brakes are applied and the train eventually comes to rest, and in another 40 seconds, okay, the train will come to rest in another 40 seconds. So one more thing that we can do is find that retardation. Okay, so we'll name this A1. Okay, A1 is the acceleration of this part, right? Here there is no acceleration, constant speed, same speed, and here there will be retardation. Okay, so we can see that during the third part, initially the train was at the speed of 40 meters, right? 40 meters per second square. Initially in the third part, you can see that the train was at a speed of 40 meters per second, right? And then it is brought to rest. Okay, so the change in velocity is minus 40, right? Final is 0, initial was 40. It was at a speed of 40, it is brought to rest. So final minus initial, 0 minus 40, minus 40 upon the time taken was 40 seconds. So the acceleration is minus 1. Okay, had to be negative, retardation, right? So acceleration is negative, brakes are applied. Okay, so I'll name this A2. Now what is the question about? The question is about average velocity. So how is average velocity defined? Total displacement upon total time, right? We already know the total time. Here you can see 20, 20 and 40, right? So 20, 20, 40, 40 plus 40, 80. So time we already know. And now we'll break that motion into 3. Okay, so we'll compute the displacement of this S1, S2, this displacement S2, second part of the motion, and third part displacement S3. Okay, so that total displacement over here by total time will give us the average velocity. So let us do that. So that will help us, that data. So S1 is I'll just use ut plus half at square, right? So in the first part you can see that it begins from rest, right? So that ut term will go, I'll just use half at square. Now what is a in the first part of the motion? 2, right? Half a t square. Time is 20 square, 400. So this and this will get cancelled. S1 is 400. Okay, now time for S2. Let's compute S2. S2 is that motion with constant velocity, same speed, right? Same speed for next 20 seconds. So simply we can use distance is equal to speed into time. Distance is equal to speed into time. So speed is 40, right? Same speed, this speed. Okay, this speed 40 and for 20 seconds. Okay, distance is equal to speed into time. So for 4 2s are 8 and 2 zeros. So 800 meters. Okay, finally time for S3. We can again use ut plus half at square. Now remember that initial velocity is 40. Considering the third part of the motion, the initial velocity is 40. It was 40, then it is brought to rest. So 40 into t. What is the time? 40 seconds, right? Plus half a. Acceleration in the third part of the journey, it's -1, right? -1 and t square. T square, 40 square, that will be 1600. 4 square, right? 16 and 2 zeros. So 1600 minus this will be 800. So again you get 800 meters. So you can see 800, 800, 1600 and 400, which is 2000. I've just added this 3. So 8 2s are 16, 8 5s are 40, right? 8 5s are 40, so 25. 25 is the correct answer. Okay, you can surely note it down. Let's go to the next question now. Okay, question 2 over here. This is a super easy question. I'm sure you'll be able to crack it under 5 seconds. Okay, so the question asks us for uniformly accelerated motion graph among this. Okay, so believe me, I'm not making this up. This is a BITSAT 2012 question. Okay, so in the first graph you can see that acceleration is increasing. Okay, basically changing. Here also acceleration is decreasing, changing. In graph C you can see that acceleration is constant, right? The value of the acceleration is same throughout the journey. Whatever time you choose, the acceleration has the same value. Okay, so this is the graph that depicts a uniformly accelerated motion. Even over here the acceleration is increasing. So super easy, right? So I think I'd rather spend a lot of time writing that question than answering. Okay, let's move to the next question now. Okay, so question 3 over here, it's from BITSAT 2010. Now a nice AT graph of a body is given. You are asked for the maximum velocity attained by that body. Okay, you can surely give it a try. Okay, I'll try it in 3, 2, 1. Pause and try. Okay, now one important observation that you can make from this graph is that first of all, acceleration is decreasing, right? So first it began with 10, then it's decreasing as the time proceeds. Acceleration goes on decreasing, and finally at 11 seconds the acceleration is 0, right? So acceleration is decreasing, one observation. Now though the acceleration is decreasing, it is always positive, right? 10, something less than that, but always positive, right? Never goes on the negative y-axis. So acceleration is always positive, or sometimes maybe at 11 seconds the acceleration is equal to 0. So what do I mean by this? Okay, acceleration is positive. So it basically means that acceleration has the same direction as that of velocity. Okay, acceleration is positive means acceleration has the same direction as that of velocity. Now, since the acceleration has the same direction of velocity, velocity will go on increasing, right? Though the acceleration is decreasing, the direction is same as that of velocity, right? So the velocity will go on increasing. So that is the idea I want to put in your head. Okay, so though the acceleration is decreasing, velocity will keep on increasing because acceleration and velocity are in the same direction. Okay, so velocity goes on increasing. That is the point. Now, so the natural question, when will be the velocity maximum? Okay, when will be the velocity maximum? Now we know that velocity goes on increasing. As time proceeds, velocity goes on increasing. So naturally, the maximum velocity will be at 11 seconds, right? At 11 seconds. So as time proceeds, velocity goes on increasing till 11 seconds when the acceleration becomes 0 and there is no further increase in the velocity, right? Acceleration is 0, no change in velocity. So after till 11 seconds, at 11 seconds, the velocity will be maximum. Okay, so that was the idea behind it. So now basically we have to find the velocity at 11 seconds. That is our whole job. Now how to find velocity from AT graph? Area, right? Area under the curve. So area under the curve, so half, you can see this triangle, half base 11 into height 10. So this will give you the velocity. Change in velocity, v minus u. Okay, so you are lucky enough because u is 0 over here. Okay, so even if you had to take it v, the answer would have been the same. Okay, so this v is velocity at 11 seconds, right? We are considering this area. Okay, from here to here, this area. Okay, this v is velocity at 11 seconds, or the maximum velocity that we want. Okay, so basically 2 cancels with this, and 5 11s are 55 meters per second. Okay, so 55 meters per second, that was the correct choice. Okay, so let's move to the next question now. Okay, so question 4 over here, it repeated in bit set twice in 2010 and 2006. Okay, so the position of the particle is given by this equation. You have to find t when the acceleration is 0. Okay, find t when acceleration is 0. A and B are constants. Okay, go ahead and try it. I'll do it in 3, 2, 1. Pause and try. Okay, so very straightforward, right? So you are given the position, so you have to differentiate it once to get the velocity, dx by dt, which will be the velocity, dv by dt, which will be the acceleration. Just equate it to 0, find the value of t. Okay, so let's do that. So first differentiate this, so we'll get velocity, dx by dt will be velocity, right? Okay, so let's differentiate that. That will give us 2at minus 3bt square. Just differentiating. Now again differentiating that, dv by dt. So we'll get acceleration. So here we'll get 2a and here we'll get 3b into 2t, right? So that is 2a. So acceleration is 0. We want to find the value of t. Okay, so 2a is equal to 6bt. So t is equal to 2a by 6b, which will be a by 3b. So again a straightforward question. The answer is C. Okay, so let's move to the next question. Okay, question 5 over here from the papers of BITSAT 2011. Okay, in this question we have a particle which begins with a non-zero initial velocity. It undergoes uniform acceleration. Now I hope you are familiar with this st and st plus 1. So basically st means the displacement of the particle in the tth second, right? Just like it's general, so let's take s2. S2 in particular means displacement of the particle in the second. S3 will mean displacement of the particle in the third second. Okay, I hope that reminds you of the fourth equation of motion. Okay, so you are supposed to tell me that relation is given and you are supposed to tell me the velocity after t seconds. Okay, so go ahead and try it. I'll do it in 3, 2, 1. Okay, so let's use that relation. Is equal to 100 centimeters. Now I hope you can recollect this formula, and those who don't know about this, it's high time that you note it down. Okay, so st, displacement of a particle in the tth second, is given by u plus a by 2 into 2t minus 1. Okay, so there is a derivation behind this which I am not going to do now. Of course, we discussed it in the regular lectures back then. Okay, so for t plus 1, all you have to do is just replace this t with t plus 1, right? So 2 into t plus 1 minus 1, right? U plus a by 2 into 2t plus 2 minus 1, right? So 2t plus 2 minus 1 plus 2 minus 1 is plus 1. Okay, so let's just substitute that over here and we'll get our answer. How? I'll show you. 2t minus 1 plus u plus a by 2 into 2t plus 1, right? So this is equal to 100. U plus u, 2u, and you can take a by 2 common and you'll be left with 2t minus 1 plus 2t plus 1 and 100 on the other side. So minus 1 plus 1 cancels, 2u plus a by 2 into 4t is equal to 100. So this and this can get cancelled. So you are left with 2u plus 2at equals 100. Okay, so you can see that you'll get u, let's take that 2 common, u plus at, okay, and 100. So basically finally what you get is u plus at is equal to 50. Okay, so and coincidentally this is the thing that we are asked for, right? The velocity after t seconds. So this is nothing but final velocity, right? V is equal to u plus at, right? So u plus at is nothing but v, which means velocity after t seconds. This is the final velocity or the velocity after t seconds, okay? So this is the thing that we were asked for. So this is the answer that we want, okay? 50 centimeters per second. Everything was in centimeters, okay? So you can note it down. Now I know that the approach to this question was not very clear. Like some of you might be doubtful that how will we reach the velocity after t seconds? How will we find the velocity after t seconds using this very random equation, right? But when you actually do it, the math is set in such a way that you arrive at the answer, right? Hopefully or coincidentally, we do arrive at the answer. So it was that type of question wherein you just do it type of question, right? So sometimes don't overthink, just do it. Okay, just do it, or at least just try to do it. Okay, so no more talks, over to the next question. Next question, question 6 on the board. You can see that it has repeated twice in our BITSAT papers, once in 2006 and then in 2013, right? So as you can make out from the question, it's a question based on relative motion, right? So you have a cyclist chasing a bus. Cyclist has a speed of 20 meters per second. The distance between them, initial distance, is 96 meters. The bus begins at initial velocity 0 and has an acceleration of 2 meters per second square. Okay, so you have to find the time at which the cyclist will catch the bus. Okay, find the time when the cyclist will catch the bus. Okay. Now, of course, the questions are framed in a very good way. I'm just making a story over here, right? I'm just printing a story over here. The questions are framed in very good words, okay? Yeah, you can try it out. I'll do it in 3, 2, and 1. Pause and try, okay? So there are many ways to do it. One way is our primitive way. You set up the equations, you solve them and get the answer. Second way, relative motion, right? Which I'm sure most of you will do. And third way, work cut relative motion, right? This was something which we discussed in episode 1 of our work cuts, I guess. Okay, editor suggests that over here. Okay, so actually we discussed a shortcut for this, a direct formula wherein we can find the time. Okay, so I'll do it in that way also, the shortcut way also, and your way, relative motion way also. Okay, so with no talks, let's begin. T equals, so the shortcut way is this. Okay, we have a direct formula, we have by hearted this, v square minus 2as upon a. Okay, so v is the velocity, 20 plus minus under root v square is 20 square, 400 minus 2as, 2 into a, 4 into s, 4 into 96, what will be that, upon a again, so 2. So 20 plus minus 496 into 4, 4 6 are 24, 4 9 are 36, 37, 38, 400 minus 384, that will be 16. 16 root is 4 and upon 2, so you get 20, either you'll get 20 by 20 minus 4. 20 minus 4 is 16 by 2, that will be 8, or either it's 24 by 2, which is 12. Okay, so either 8 or 12. Just an error from my side, this is not 12, this is 10. Okay, so you have to select one answer among this. You'll have 8 and 12, so 8 is the answer that we have in our options. Okay, now let's do it by the relative way, right? This was the shortcut way which we tried. Now let's do it by the relative way. I'll just form the equations and I'll solve it. So relative way, we'll watch relative to the bus. Okay, relative to the bus, let's watch the situation. Okay, so this man has a speed of 20 meters per second. Flip this acceleration, flip that acceleration and give it to him, right? Flip and keep. So acceleration of 2 meters per second square has to cover a distance of 96 meters. Now the bus is at rest, right? We are watching relative to bus. Bus has flipped its acceleration and gave it to the other guy. Okay, now let's find the time required. So basically we have to write s is equal to ut plus half at square. So s is 96, right? Displacement will be 96. Ut, velocity into time, which we want to find, plus half a. A is -2, right? This direction is positive, this direction is negative. Okay, acceleration is opposite to velocity, so that's why minus, and t square again. So this and this will get cancelled. We'll have t square minus 20t plus 96. Okay, now you can see that this can be factorized as minus 12 and minus 8, minus 12t. Now this can be factorized as minus 12t and minus 8t, right? So that adds up to 20, and if you multiply you'll get 96. So the same answers you will get, t minus 12. This can be factorized in this way. Okay, so the same answers you will get by relative motion, by the concept of relative motion too. Okay, that was a shortcut. Okay, so let's move to the next question now. And if you find it worth noting down the shortcut, do note it down. Okay, it might help you someday. Over to the next question. Question 7, all the way from BITSAT 2005. Now I'll explain you the story, what's happening. We have with us two stones, okay, one with mass m, other with mass 2m. Okay, so the one with mass m, we are going to throw it vertically upwards with velocity of u. Okay, so once we do that, we find that the maximum height achieved by this stone is 50, right? So now we are going to throw the second one, the second stone with the mass 2m with double the velocity, 2u, right? So what will be the height x achieved by it? What will the maximum height achieved by this? Okay, so go ahead and try it. I'll do it in 3, 2, 1. Pause and try. Okay, so the smart ones among you might know that this mass is given just to confuse you, right? Nothing depends on the mass, because acceleration here will be g and here also it will be g. Okay, so the mass is just to confuse you, and some of you all might directly know the result that the height is directly proportional to u square, right? This is a result from motion under gravity, wherein we said h max, the maximum height achieved, is u square by 2g, right? And where does this come from? This comes from the equation v square is equal to u square plus 2as. Okay, so at the highest point, okay, suppose this mass has reached the highest point, you know that at the highest point, at the highest height, the velocity, the final velocity will be a 0, right? The velocity is 0, that's why it's not going up, right? So velocity is 0, it won't go any further up. Okay, and then gravity is still pulling it, so it comes down. Okay, initial velocity, let it be u, and you know that acceleration is g minus g, since it's in the downward direction, and h, we'll call it to be h, right? This height to be h. So from here you can see that h is equal to u square by 2g, or simply you can say that h is proportional to u square. Okay, so here let's, u is proportional to 50, u square is proportional to 50. Okay, let's write it in a proper way. H, 50, is proportional to u square. Now x will be proportional to 2u square, right? 2u the whole square. Okay, now you can simply divide this. Okay, so 50 by x, even if you had equal to, so we can simply write it this way, equal to k, right? Proportionality constant, and once we divide that, that is going to cancel out. So u square by 2, 4u square, right? 4u square, u square gets cancelled, and the x, the height that you get from here, is 4 into 50, which is 200 meters. Okay, so 200 meters is the correct answer and not 100 meters. Okay, so over to the next question now. Question 8, you can see that it has repeated over the years. Now I'll explain you the story of this question. It's actually a very typical question. It can be solved in a very typical way. Okay, so pay attention. The story goes this way. You have a tower of height h. So you go to the top of the tower. For first time you throw a ball with velocity u in the upward direction. Okay, so that goes up and back, falls back to the ground. Okay, so the time taken for that journey to happen is t1. Okay, now second time you throw the ball in the downward direction. Okay, with the same velocity u, you throw the ball in the downward direction. Okay, now time taken for that journey to happen is t2. Okay, keep that in mind too. Now you go again to the tower, and this time you just drop the ball. Okay, you just drop the ball, initial velocity 0, you just drop it. So the time taken for that journey is t. Okay, so all you have to do is find the relation between t1 and t2. Okay, now it's a typical one, so I'll do it directly. Okay, so let's take the conventions first. Let's take the upward direction to be negative and downward to be positive. Okay, you can choose it whatever way you want, the other way around. Okay, so all we have to do is to write s is equal to ut for ut plus half at square for this one, and then just compare. Okay, then just manipulate and compare. So let's just do that. So for the first one over here, so h, right, downward is positive. So displacement, if you see, is h, right? Of course it goes up and down, but that is distance, right? We want displacement. S is equal to ut plus half at square. S is displacement, shortest distance from initial to final point in the downward direction. You can see that. So it will be positive. Okay, so h is positive in the downward direction, and you have u in the upward direction, which means it's negative. Time taken t1 plus half. G is positive in the downward direction, right? t1 square. Okay, again for the second one, the displacement is again h. Now u is in the downward direction, so positive plus half. G is also in the downward direction, so positive, and t2 square. Okay, so now why is it typical? Because next step is very random. Okay, all you have to do is multiply this with t2, since there are t1 terms over here, and this with t1 since there are t2 terms over here, and then add them. Okay, the advantage of doing this is you'll get rid of this term, so you'll get minus u t1 t2, and here you'll have u t1 t2. Okay, so that will get cancelled. Basic idea. Okay, so once you do that, you'll get h into t1 plus t2, right? This will get cancelled, and you can take g by 2 common, and also you can take t1 into t2 common. Okay, t1 into t2, and you'll be left with t1 plus t2. Okay, you can open this and verify, you'll reach back there. Okay, so now this and this will get cancelled, right? t1 plus t2 is of course not equal to 0. This is some finite time, right? Not equal to 0, so you can cancel on both the sides. Now you will get 2h by g, I'm just rearranging, is t1 into t2. Have you seen this somewhere, right? Have you seen it somewhere? Does it click you? Okay, so basically the time of journey for this journey to happen is, if you remember the result of motion under gravity, it was under root 2h by g. From where did this come? It comes from s is equal to ut plus half at square, right? So you just use h is equal to ut, so initial velocity 0, half at square, half gt square, right? So 2h by g is equal to 2h by g is equal to t square, or t is equal to under root 2h by g. So here, look at this. So here you can replace it by t square. Okay, so finally the form in which we want the answer is, okay, so I want you to remember this as a result. Okay, remember it as a result. Remember this question on a whole. Okay, you can remember that the time for free fall is the geometric mean, right? This is the geometric mean, root of AB, right? So root of T1 into T2, the geometric mean will be the time for free fall. Remember this question as a typical one. and remember the final result, right? It's so easy to remember as a geometrical mean. Okay, so this was a typical one. I know it was a tough one, my boy. Okay, so let's move to the next one now. Okay, question 9 over here. Now this question is purely a play of visualization. Okay, so those who are good at visualization will get it within a go. Okay, so okay, I have to tell you the story now. It's from 2007 first of all. Okay, so you have a ground, and on that ground you have a hot air balloon. Okay, so that hot air balloon begins with an initial velocity 0. It has some acceleration in the upward direction, which is 1.25 meters per second square. Okay, so after 8 seconds, this will be the scenario, right? The balloon will rise up in the air, right? It has some acceleration in the upward direction. It will rise up in the air. Okay, it will gain some velocity in that direction and it will go up. Okay, so after 8 seconds, you are going to drop a stone from that balloon. Okay, you are going to drop a stone from that balloon. So you have to comment on that stone. Okay, basically you have to comment what will happen to that stone. Okay, so does it begin to move down after release? Does it reach the ground in 4 seconds? Does it cover a distance of 40 meters, or will it have a displacement of 50 meters? Okay, go ahead and try it. I'll do it in 3, 2, 1. Okay, so the basic idea that you have to grasp now is that, see, this balloon is moving up, right? It's gaining some velocity due to that acceleration, right? So it has some velocity. You are in that balloon, so you will gain the same velocity, right? You do not fall off that balloon. So basically you have the same velocity as that of the balloon, right? In fact, everything in the balloon has the same velocity as that of the balloon, of course, right? Very obvious. So even that stone will have the same velocity as that of the balloon. Okay, so at 8 seconds, when you leave that stone will leave with the same velocity as that of the balloon. Okay, so at 8 seconds, whatever velocity the balloon has, the same velocity will be given to the stone as it leaves. Okay, so that is the idea. Now let's try visualizing it. Now this won't be perfect, I know, I agree. Okay, so let's take this to be my hand, to be the balloon which is accelerating, and my fingers to be the hand that's going to leave that's going to drop that stone. Okay, so once look what's going to happen. Okay, so once I leave this, okay, so can you see that the stone goes up, or the object goes up and falls down, right? So why did this happen? Because the object is leaving with whatever velocity my hand had before leaving it. Okay, so that is what I said. The stone will leave with the same velocity as that of the balloon at 8 seconds. Okay, so that was the basic idea behind this. Okay, so so now let's solve it. So we know that stone will leave with some velocity. We can find it by finding the velocity of the balloon at 8 seconds. Okay, but let's just assume it to be v. Okay, so of course we know that stone will move in some upward direction and then fall down. Okay, now we know that the stone will go up due to that velocity, due to the balloon. Okay, and it will go up and then fall down, right? Like that object. Okay, so here, let's come to the options directly. Begin to move in the downward direction after release. Is it so? No, because it moves up, and somebody who is watching it from ground will see that as if it's moving up and then falling down, right? So this is not the correct choice. Reach the ground in 4 seconds. May be correct. Cover a distance of 40 meters. May be correct. Will have a displacement of 50. Okay, so let's find the displacement. Okay, let's find the displacement, this displacement. So basically we can find the displacement by using S is equal to ut plus half at square, right? We can just find the displacement of the balloon after 8 seconds, right? So that will be the displacements of the stone as well, right? That's the point where we are leaving the stone. Okay, so half a acceleration of the balloon, 1.25 is 1 and 1/4. 1 and 1/4 is 5/4. Okay, so 5/4, and t square is 8 square. 8 into 8, 4 2s are 8, 5 8s are 40. So displacement is 50 meters. No, displacement should be 40 meters, right? The shortest distance from here, from the point of release to ground, should be 40 meters, not 50. Okay, covers a distance of 40 meters. Now displacement is of course 40, but does it cover a distance of 40 meters? No, right? It travels up in the air and back to the ground. So some extra distance, right? Not just this 40, but that extra distance as well. Okay, so this is also wrong. The only answer we are left with is B, right? Such a simple question, only pure imagination or visualization required. Okay, this time can be also found out. Instead of negating the options, you could have directly found out the time. Okay, so first we have to find that velocity, right? Velocity of the balloon at 8 seconds, or velocity of the stone at the point of release. Okay, so that basically will be 80, right? U is 0, so 80. A is 5 by 4 and into time 8 seconds. So that gives us 5 2s are 10. So velocity is 10. So that is the initial velocity of our stone, right? Initial velocity of our stone. Just use S is equal to, S is minus 40, right? Minus 40 ut. This will be the initial velocity into time minus half at square. This g is negative, so gt square. Okay, so I can use 10 in place of g. So we'll get 5. So 5t square. Now just solve this quadratic. 5t square minus 10t minus 40 gives you 0. So t square just divided by 5. 2t minus 8 gives you 0. Okay, so 8, you can say 4 2s are, right? 4 2s are. So 4 and 2, but we'll have minus 2, right? Minus 2 minus 4. Okay, so t minus 4 and t plus 2 factorizes this. Okay, so this can't be 0, right? Time cannot be negative. So the only answer we are left with is t is equal to 4 seconds. Okay, that was the way to find it out. But we went by the negation way and pure visualization. Okay, so let's move to the next question now. Question 10 over here. Now the story is quite simple. You have a bigger sphere over here, hollow, and in that you have a rod AB. On that rod you are going to make a small sphere roll. Okay, so what you are going to do is just leave a small sphere, tiny sphere at that point A with initial velocity 0, and due to gravity it is going to roll down, right? Roll down across that length AB. So the question is, what is the time taken for this tiny sphere to reach the point B? Okay, what is the time taken for that sphere to reach point B? That is the only question. Okay, so go ahead and try it. Okay, don't get confused by that. That is for my personal use. Okay, so I'll do it in 3 2 1. Okay, so basically all you have to do is just use S is equal to ut plus half at square. Okay, you can see that initial velocity is 0. S is nothing but this distance AB, right? So AB, so twice into AB. I'm just shuffling that so that I can get T. Okay, T will be this thing, right? Twice into S. S is AB. Displacement when it travels the distance AB will be AB, right? And acceleration, some acceleration. Now what is the acceleration that we have to find? And we have to find that AB. Now AB we can easily find using cos theta. So just write what is cos theta. Cos theta is AB by AC, right? Now you can see that adjacent to theta will be 2r cos theta, right? So AB will be 2r cos theta. Okay, so anyways, AC is nothing but the diameter. Okay, so I can replace that by 2r. So AC is nothing but 2r, right? By magnitude it is 2r. So you can say that 2r cos theta equals AB, right? So the value of AB you got, let's substitute that, 2r, and you one more 2 you have, so 2 into 2r cos theta. Okay, now what about this acceleration? Now let's try to find it out. So this angle is theta, suppose. Now I have constructed one more triangle. Okay, this will be 90 minus theta. This angle is 90, and this is 90 minus theta. Okay, so now you have to find that acceleration when you drop this tiny sphere from here. Remember I told you this in projectile on an incline, right? Rather you might know this from your Newton's law of motion, right? Laws of motion. that along the incline, the force which is there is mg sine theta, right? Or rather, more generally, let's state it as g into the acceleration. I am stating g into sine of angle of inclination. Now you can note that the angle of inclination is 90 minus theta. Okay, I've drawn an incline like that. Okay, so g into sine 90 minus theta, and perpendicular to the incline you'll have g cos into angle of inclination 90 minus theta. Okay, but we are not concerned about that, because the one who is causing motion is this g sine 90 minus theta, right? Along the AB rod you have g sine 90 minus theta. So the acceleration is g sine 90 minus theta, or sine, what is sine 90 minus theta? Cos theta, right? Okay, so let's just substitute that and we'll have our answer. Okay, so g cos theta t. So cos theta cancels cos theta, and you will get this 2. So one of the two we can get it out of the root sign, and 2 under root r by g. So C is the correct choice. Okay, so it was quite simple, right? Only we need a little bit of thought process over here, and how to find AB and how to find A. Those two things were a bit tricky. Okay, let's move to the next question. Okay, question 11 over here. This is something that we discuss in our introductory classes on motion in a straight line, right? So in this question, I'll just explain you the question. There is a car which moves 2/5 of the initial distance, 2/5 of the total distance of the journey with velocity v1. It moves the next 3/5 of the distance, total distance, with velocity v2. Okay, you have to find the average velocity of that car. Okay, so the question is about average velocity. Okay, so this is not a bit set question, this is just a practice to you. This type of question has never appeared in bit set, so might come this year. Okay, so let's do it. So average velocity, how is it defined? It's defined as total displacement upon total time taken. So let's consider that this distance is x. Okay, so let's consider the total displacement is x. Now time you can break it in two parts. So t1 will be time is equal to distance upon speed. This distance is 2/5 of the entire distance, right? 2/5 of the entire distance. Okay, and time is equal to distance upon speed. Also time 2 will be similarly 3/5 of the total distance, 3/5 of the total distance x upon r v2. Okay, so here we'll have 2x by 5 v1 plus 3x by 5 v2. Okay, this x will get cancelled. We are left with 1 upon 5 v1 plus 3 upon 5 v2. Sorry, 2 upon 5 v1 plus 3 upon 5 v2. Now let's just simplify that. So the answer that we get is 1 upon, so 5 2s are, so I can just take that common, right? So v1 into v2, 2 v2 plus 3 v1. Now just flip it, so you'll get 5 v1 v2 upon 2 v2 plus 3 v1. Okay, how difficult is it to say that? Okay, so this is the answer that you should get. Yeah, okay, so you can note that down. I'll give you your homework question, then some tips, and we'll wrap up today's class. Okay, so this is your homework question. I'll just explain it like a good storyteller for one last time. Okay, so you have three cars A, B, C. Initially the distance between them is D, between A and B is D, B and C is also D. Okay, so A moves with a velocity of 5 meters per second, B moves with some unknown velocity u, C moves with some velocity 10 meters per second. So after some time, what happens is that B catches C, okay, B and C meet, okay, B and C meet, and that time the distance between A and B or A and C will be 3D. So you are supposed to tell me what is the value of this U, okay. So do comment the answer in the comment section, and the correct answer as usual will receive a heart from me. Okay, so few tips before I leave. Now don't take this as the only tips, okay. Take this as some general observations, my general observations from today's video, okay, from today's lecture. Okay, so first observation is that you can split these questions of motion in a straight line in two parts, easy and second category is moderate to difficult. First category easy, second category moderate to difficult. Now easy were the questions that we discussed in the beginning of the class, right? First 6 to 7 questions, okay. So those questions are like concept based, of course concept based, but they include direct application of concept, direct application of concept, direct application of a formula, and then you get the answer, okay. So that's why they are easy. Now coming to the second category, it includes a bit moderate questions, right? Now the only difference is it requires a bit of thought process, okay. They are also concept based, but it requires a bit of thought process. You need to think in a particular direction, right? So for this, to develop this thought process, what you can do is either practice quantitatively, like take a lot quantities of questions, practice a lot of questions, or quality, right? Focus on quality. There are two ways, okay. Try good questions, okay. Now at this stage of preparation, I'll suggest you to lean towards quantity, right? Rely on quantity. Practice more and more questions. Searching good questions takes time, which you don't have, of course, okay. So with that being said, let's wrap up for today's class. I hope you enjoyed it. Do follow the word series going on my Instagram. That will help you boost your score in the English section of the paper. Also, you add subscribers, I add videos, okay. So let's meet in the next class. Till then, keep enjoying physics.